well today? All right. So, good afternoon once again. I hope my screen is visible to all of you. Can you see my screen, the laptop screen? All right. Thank you, Shekhar. So, in our next series of lectures, we will be trying to understand the software design and a specific kind way to go about software designing, which is called as object-oriented design. So most of you may be familiar with object-oriented programming. So generally the fundamentals of the object-oriented programming we will be discussing here, but in much more deeper manner, and we will try to understand that how designing your software on paper using object-oriented design actually leads to much clarity over the implementation aspects as we move forward in our software development. So hopefully you will be able to understand better about software development throughout these lectures, and I'm sure that as you are proceeding in your projects through the use case diagrams, through the functional decomposition, through the data flow diagrams, and obviously the level 1 and level 2 data flow diagrams, I think uh, as you are understanding software development through these activities, object oriented design in that direction will lead you to a much more deeper understanding not only of the design, but here we will make a connection between the designing and the implementation, because that is what the objective of this kind of design. It actually helps you provide a mirror, if not a perfect mirror, but a mirror in which you can exactly see how different entities are interacting with each other and the attributes and operations of all these objects. So with that background, we start with understanding the object oriented design, and things will become more clear as we will also take up object oriented design in our lab sessions. So as we are talking about design phase, so before starting to specifics, it is good to remember and remind ourselves that in design phase what is basically happening is that we are transitioning from what the system must do to how the system will do it. So when we talked about what the system must do, we talked about the functional requirements of the system. You also gathered the requirement specifications, you analyzed them, you validated them. So that was about what the system is supposed to do, what a software is supposed to do, what an app or a website is supposed to do. That was pretty much clear. When you design your use case diagrams, you had different actors and you understood that, okay, how different actors are interacting with your system and what they are getting out of it. In design phase, we move on from what the system must do to how the system will do it. So the how part comes into picture. But at this stage of how, we are sort of preparing for the implementation how. So that is why in design, we transition from the specifics of what the system must do to how the system will do it. So mostly in object oriented designing, we talk about classes that we need to implement as part of our overall solution. Now, what are the different attributes and methods each of these objects will have, and how the different classes and their instances will interact with each other. So this is what we will be going to talk about in the detailed designing phase. So essentially, when you're trying to design a system, what you're trying to do is you're trying to model the system. When we talk about modeling, so we are trying to understand on a deeper level and also at a much more easier to understand level what the system is trying to do. So again, the question arises, why do we need to build a model? Because when you're trying to, and in universities mostly we have experience of working on certain small level projects. Maximum you can reach to 2000 line of codes or 3000 line of codes, but the giant softwares are made up of millions and millions of codes, and modeling a smaller system is relatively much more easier than modeling a complex system. But essentially, what modeling helps us is to understand the system we are developing before we develop it. And when we are working on building a complex system, it is very important to be able to get the model right. Because if we immediately jump to create the model without actually having a model of it or having an indication of how the different entities interact in it, then we will have to come back to the designing phase. And always remember that reverse pyramid in the class that I had shown. Implementation stage is dependent on the precision and the depth in the design stage, which in turn is related to the accuracy with which you have gathered your requirements. So all these things are important to be kept in mind. So we create a model before actually implementing the software, because it sort of helps us to understand better what we are trying to create. We can see the structure of the system, the behavior of the system. So there are different views of the system in modeling. So you can create model based on different types of views. You can create a model for user. You can create a model which is called a structure view, a behavioral view. So essentially, I want all of you to understand is that uh, designing and modeling of a software prior to implementing it is not a task that has been thrust upon you, but it is something that will lead you to a deeper understanding of what is happening in your project and what you're supposed to do. For example, if some of you can help me understand how making a use case diagram and how making a functional decomposition diagram and how making a context diagram has led to a better understanding of the problem. So, do you think that after your use case diagram was developed, or after you were able to create a first level or first draft of your functional decomposition, did you feel that you were able to understand your system better? Any comments on that?
Yes, ma'am. Like, if we, am I audible clearly?
Yes, yes, you are.
Yes, ma'am. When we write it down, instead of keeping it in mind, the brain gets freed, and we can see it, and it's easy to understand and move forward rather than keeping it in mind. So,
So what was easy to understand? How did creation of such design help in understanding of the system that you are going to develop?
like when we offload the mind about the details which are not required to be remembered, we can get creative by giving it some free space. So it would be better to do, and it makes us clear to what to do, and we can see it
Okay.
in just one page, and everything in, I mean, app, everything how interacts it's, I mean, every entity how interacts, I mean, how it interacts will be in front of our eyes, and we don't need to say like imagine what happens like.
Okay. So in turn, it maybe it led you to somewhat deeper clarity about the problem you are solving.
Yes, ma'am. If we also have any mistakes, we can see it if we draw a diagram rather than keeping in mind. We may overlook them when we keep them in mind.
And so yes, definitely, such designing and such modeling helps you to visualize your system much better, and that is why they are important. Now, there are certain principles that need to be kept in mind when you are going for modeling your system. So, choice of model has profound influence on how a problem is attacked and how solution is shaped. So, there are different kinds of models. There are static models, there are dynamic models, and it's not a question of which one is better than the other. It's always a question of what the purpose each of them are fulfilling. And each of these choices of models or each of the types of models have a different goal behind it, and they are trying to provide you a different way to look at your system. So the choice always matters, but obviously, when we're starting to understand software engineering, we start from the very basics and moving towards complexities. And in advanced software engineering, if you will take a master's sometime later, you will learn about the advanced models that are also used in software designing. So the second principle of modeling is that every model may be expressed at different level of precision. So normally in use cases diagram, more than 20 use cases are not permitted. And and when we talk about data flow diagrams, so there are first level data flow diagrams, second level data flow diagrams. So again, every model can be expressed at a different level of precision and a deeper level of precision. Depends on absolutely what your team wants and how much clarity you want. So that's the second thing. The third thing is that uh, the whole point of creating a model is to be able to understand your system, like the DNA or the blueprint of your system, before you start hitting the keyboard to actually implement the system. So the best systems, the best models should be connected to reality. That means when you see your own model or own software design that you have created, you can see what exactly is happening as the app or the software is supposed to behave in the real world. So uh, it should be able to give that kind of flavor. And it is no, I mean, it's not hidden that no model is sufficient, but every model contributes to an understanding of the system that you are trying to create. So always remember, everything in life is a process, and so is modeling. So when we start building the individual box and then go on towards the non-trivial systems modeling, so it is best approached through a small set of nearly independent models. So it would not be too bizarre to become really a child when we are trying to create a software model, because then we can see how different entities come into picture to interact. And I can understand that from a multiple iterations of your use case diagrams, you will have experienced this yourself. And as we will again review your functional decomposition and data flow diagrams, these things will become much more clear and precise. So there are certain groups who are continuing to talk even for the use case diagram, and I can clearly see uh, the growth and the accuracy that has come up in the after the multiple iterations of the diagram. So again, no model is sufficient, but each of them provides some kind of understanding. So these are certain principles that you must remember. But out of this, if you have to really prioritize, I would say that your model should be intuitive in nature. It should be able to express the both the simplicity and complexity in a rhythmic manner, and it should be easier to understand, and that is extremely challenging to get. But again, it's a structured and process, so it happens as we proceed. Before I talk about object oriented designing, you must have read about object oriented programming in which year? In second semester or third semester or first semester? Which semester were you introduced to object oriented?
Second semester.
Second semester, okay. So, what do you think led to the uh, origin of object-oriented programming? What was wrong with the traditional or classical programming paradigm that object-oriented programming was introduced? What do you think?
I mean, taking care of data flow was difficult in procedural programming. So,
Okay, anyone else? So now that you are in third year, you must know and understand, just like we understood how the previous software development lifecycle models had certain shortcomings that led to more advanced software development lifecycle models. You must also know what was it that led to object-oriented paradigm. What was the reason behind it?
also the procedural programming way doesn't cope up with the models that we think as a human, like things. And so I mean, if we have different kinds of people, they have different styles of eating or anything. Like they just eat, and like with the same activity, there comes a different kind of output. Similarly, when in procedural programming, we need to use switch cases to do that. If person is left-handed, he must eat with left hand, or right hand. We use it to use switch cases for this. But after coming of object-oriented programming, we just say person.int and it happens. We don't
Yeah.
need to think about what is internally here. That it's already programmed with the object, so
Yes.
it's not possible in
Yeah.
procedural
So
programming.
yes, you're talking about the ability to reuse the
Message
existing.
passing,
Yeah.
message passing.
Passing and the ability to reuse the piece of code if a new functionality is introduced in the system. That was easier with object oriented than with the classical. So, with the traditional approach, and I will also share a paper after today's class. An IEEE paper talks in detail about these two approaches to modeling. So, the thing is that procedural programming was an original or classical way to attack the problems in which you are actually dividing the bigger chunk of problem into collection of procedures or functions. So imagine it like a top-down approach. You are trying to understand how the different functions model up to the final functionality that the system is supposed to provide. Whereas in object-oriented, so in procedural, the data and functionality were kept separate. Object-oriented brought these data and operations and data and methods together, and because of this kind of structuring, moving from one phase to another became easier, and it was easier to also check out for the errors and complexity and all these kind of things that are associated with object oriented system development. It basically made project easier to manage and scale, which was very difficult in the procedural programming. If a new demand were to come up and you were using procedural programming, it would be very difficult to incorporate in the existing system. And if a single variable were to be changed by multiple functions in procedural programming, then it would be very difficult to identify uh, which function is exactly changing that. So that led to introduction of procedural programming. Just give me a moment. Yeah. So, whenever we, am I audible? Can you guys hear me?
Yes, ma'am.
Okay. So thank you, Tarun. So whenever we always remember, whenever we move from old technology to new technology, it's extremely vital to understand what is the reason that we are moving to a new paradigm. So maybe procedural programming would have worked for smaller line of code, a small piece of software, but as and when the software became more and more complex, it became easier to difficult to maintain, and so that is why a different way of thinking, a different way of looking at the software was necessary. Now, when we start out programming, we all start out with procedural programming, and then gradually, when we are well versed with what we are trying to do, then we try to think, okay, it would be better to create function for this so that I can reuse it again and again. So, all these kind of things, and object-oriented system also allowed you to interact with the outside objects better because there is no limit. The limit is only in the imagination. So the way you use your object-oriented system development. So this is a simple code snippet in which a simple bank account seems to be developed. What do you see the difference between when you look at these two code chunks? What is it that strikes out? What is it that is striking? What is the difference that you can see here?
Visually, it's apparent that the object-oriented code is less than the, height is less than this procedural one. And also it took more lines to, both are same, whatever I'm saying.
Yeah. So again, the complexity and all these things that we're talking about, object-oriented manner allowed you to target and tackle your problems in a much more structured and I would rather say stylish manner. But never think that this is procedural all or object-oriented manner. Sometimes we have to use a combination of both. So to understand this better, let us try to see this video. So is the screen visible to all of
In
you?
this next set of videos,
Yes,
we're going to
ma'am.
walk through.
Uh,
Yes, ma'am, it's visible.
Okay, the voice is clear.
Yes, ma'am, audible.
Okay, so let us try to watch this video, and then I will ask you what you get out of this particular video.
Various ideas around object-oriented programming and how to technically implement a number of different techniques that are used within Drupal and also used across the board on many object-oriented based projects. So at its core, object-oriented programming will give you a better model of how to organize your code. Now, a lot of PHP programmers started by simply hacking away and trying to get something that's functional. And what you end up with is something called procedural code. You have variables and you have functions, and the role of the functions is to get from point A to point B. It's to complete some kind of task. So for example, we might convert data from one format to another, or we might take some data in an array and organize it according to its alphabetical order. And the idea is that you're constructing your code so that you step through these different procedures. Now, after you have some programming experience, you start to realize that a lot of these functions can be generalized, so you can use them in various other situations. So for example, if you have that function that sorts items in an array alphabetically, you might find that useful to convert other types of data into an alphabetically ordered list. For example, some XML or a set of strings. And as you start to think this way, your mind is actually going more towards object-oriented programming. You're thinking about these functions as these little machines that can be used in different situations, not just the original situation that they were intended for. When you start to dive into tutorials about object-oriented programming, you'll find that people use real-world objects as examples, because in a big way, the world is very object-oriented. The idea is that as you look around you, you see yourself surrounded by these different objects. And objects are basically anything that you can give a noun to. So for example, right now, I'm surrounded by my computer, a glass of water, and a lamp. Because we can name each one of these things, they're really objects. And in the real world, objects aren't limited in the way that they can interact with one another. So for example, I can use the lamp to illuminate the keyboard on my computer. I can use it to see through the glass of water that I have. I can take the glass of water and dump it on the computer. And really it keeps going. But the idea is that the interaction between the objects in our world are limited more by our imagination rather than any limitation in the object itself. Now, if you apply that idea to your code, then what you should end up with are these components that can be used in ways that were unanticipated at the start, because you have modeled the behavior of that item and contained it in an object. And it turns out that this is actually a pretty natural way for code to be organized. Now, the tricky part at first is taking that idea and seeing how it relates to code. Because most of the time when we're dealing with code, we're dealing with kind of abstract concepts. We're dealing with things that don't have a parallel in the physical world. For example, on a website, we have images, we have forms, we have blocks of content across the page and templates. We can call each of these things by their name, which is a noun, and that indicates, at least on some level, that they're objects. In addition, there are objects that have more abstract ideas associated with them. For example, a calculator that performs some operation on the data that gets sent to it. Or, in the example of our function that sorts alphabetically, we have a sorter. Those little bits of code are like machines, and they're our inventions. We can give them whatever name we want, but they're objects that didn't really exist before we created them. Now, if you don't immediately see the application of this different way of looking at your code, that is looking at it as objects rather than a set of procedures, that's okay. That sort of perspective comes from actually working with it and seeing how the code is organized and what kind of benefits arise from organizing it in that different way. So just let some of those ideas start to percolate, and we're going to start getting our hands dirty. And along the way, we'll talk about the implications.
So that was the video which talked about how object-oriented designing can be introduced in the thinking before it is introduced in the coding. And again, it takes a lot of practice and working with different kind of solutions. So that is why, again, when the scalability of the project increases, definitely there will be issues with procedural kind of programming. But it is important to understand the procedural design before we move on to the object-oriented design. So what happens in procedural design is that essentially a large program is divided into smaller programs, which are called as different names like programs, subroutines, and functions. And each function solves a part of the problem. However, when the size of the project increases, it can become extremely difficult to follow this kind of design. And normally, what happens is, see, any code that you write in your lifetime, you will not, there are chances that you will not be the only one who's interacting with that code. If someone is working on that code later on, so for example, in software companies, the codes have been written, and the software engineers and developers are working on that piece of code and trying to solve the bugs. Or so bug fixing is one of the majority of activities that is undertaken in the software corporations. So, and everyone has their own style of coding and fixing the bugs. However, at times what happens is that if it's a large program and one is not aware about the deeper level of design, what can happen is that fixing one of the bugs may trigger a bug somewhere else, and that will lead to difficulty in protecting the data from inadvertent changes. So that would create something called as a spaghetti code. So when you're trying to actually debug and trying to understand where exactly is the problem coming, it will almost look like you're trying to lift a spaghetti by the fork. So spaghetti problem is one of the major problems when it comes to code which has been poorly structured, and it is a very common problem, especially when that code has been worked upon by software developers uh, who may not know in deep about the fundamentals of object oriented programming, or who may be just focused on fixing the bug at hand without understanding the implication of the quality of that fix, the nature of the fix. So that is why code reviews are also taken later after. So it's not only important that the problem has been fixed, it is important also to understand that the problem that has been fixed in a certain manner has not triggered a problem somewhere else. So that is easier. And in procedural design, so it suffers from certain other functionalities which are related to object oriented design, but again it was not thought after when it was in the functional stages. So think of C as considered as a procedural language, whereas C++ is considered as an object-oriented language. And if you understand the difference between these two, it would be easier to relate to understand the difference between the designing aspects of them. So this, I think it's already covered, but just to reiterate, so procedural, as the name suggests, is about the idea of getting things done in a sequence manner. And all of us start with procedural programming when we are trying to tackle the problem, because the first thing that on our mind is to somehow get this problem solved. Only after we have been with that problem for quite a while, then we want to tackle it in a different manner, which is much more cleaner. And then we start understanding what the speaker was talking about in the YouTube video. So going forward, this is something which is called as the spaghetti code, a code which is written without any proper coherent structure. Now, there are certain reasons that a spaghetti code or software would might happen. What do you think would be the reasons behind such kind of situation? What could have led to a spaghetti code or spaghetti software?
Obviously, not understanding it and proceeding. One thing.
Understanding what?
Understanding the I mean, complete without completely understanding it and moving forward on it. I mean, the project or whatever we're going to do, the code or already pre-existing code,
Okay.
whatever we are taking it, without understanding, if we do something, it may break something else. We need to, if we are breaking something else, we need to understand why it is there in the first place, and then we need to do something without affecting the
Okay.
causes it may cause. So without doing this may pull other thing and other thing. Just as when we eat noodles, everything comes all of a sudden.
Okay. So there are two kind of things. Maybe a software was started off quite structurally, but over the period of time, there have been a lot of bugs, and the way they have been fixed have led to this kind of problem. The second situation would be that you're trying to develop a software, try to develop an app from scratch, and without going through the designing phase and modeling phase, you have immediately started writing the code for the software. So then there are chances that because your approach has not followed a coherent structure and has been done in an unplanned manner, so there have been convoluted coding structures. So basically, you are trying to just fulfill the functional requirements somehow and without actually paying attention to the structure. So a poor design, a poor model of the software would definitely always trigger a problem like this, and that is why later on we don't suffer from this problem. It is important that we try to create a better design and model for the software. The second drawback is that it will become extremely difficult to debug in the code like this. You will not understand where the dependencies are there, and it will, especially when the software is complex, it becomes very difficult very quickly. So I'm not saying that it will not be difficult in object oriented, but I think your search and your investigation behind the debugging aspect would be more systematic and organized, rather than when the code itself has been just done in a procedural manner. So always remember this. So I hope you are getting the idea that uh, introducing software designing and modeling is not just a pain that you have to undertake, which will uh, elongate the time that you are spending to create your software development or software product. It is actually a very wise investment of your time before you go on to implementation, because uh, when you are implementing, then you can directly see that the quality of your implementation will be directly dependent on the quality of your design. So that is extremely important to remember. And this is not only about software development. I think if you undertake any project anywhere, if you move through the analogous lessons that you have learned in software engineering class, tackling those kind of problems and projects will become much more easier. All right. So let us take an example. Let us take an example to understand procedural programming from object-oriented programming. So suppose you're working for a vehicle parts manufacturer that needs to update its online inventory system. So for updating of the online inventory system, certain forms are there. So maybe different forms are maintained for cars, trucks, and the cars and trucks have different attributes. So but there are some common attributes, but there are different attributes like car number of doors, and for trucks, let's say, I mean, don't look at the meaning behind them, but let's say there are different attributes. Now suddenly if a new demand comes up and you're required to add a bus form, then you will need to create a form from the scratch for the bus. So that would be a procedural approach. In the object-oriented programming approach, what you can do is that if you were to create a class, then a vehicle class, then you could inherit a bus class from the vehicle class and add a new method for that. So try to imagine like this, the difference between procedural and object-oriented. This is very important to uh, discuss, because then you can appreciate in a much better manner what exactly are the benefits of the object-oriented designing module. So in short, this is the difference between procedural and object-oriented programming. And you can also look at difference between designing. So procedural generally follows a top-down design. The code reusability is extremely limited. The code can get complex, and complex not because of the nature of the code or the lines, but because it is disorganized and it's sort of convoluted in certain manner. So it can be difficult to understand. And whereas in object oriented, reusability is there, the complex design is there, but then when you try to look at how it has been compartmentalized, it becomes easier to play with those kind of objects and classes. And again, access modifiers are available in object-oriented programming, which may not be available in procedural kind of program. So it's an entirely new platform and has revolutionized the way we have started to think about software development. So with that background, we come to the object-oriented design. A little bit of history we have already discussed. So again, classical technique was quite common, but between 1975 and 1985, dissensions started coming up, and these would have worked well. And in fact, in our colleges also, when we are learning how to create softwares, all of us follow a structured paradigm. And by the time we are experienced, we try to introduce object-oriented, but it becomes extremely challenging to follow such kind of approach when the scale of the project and the complexity of the project begins to increase. And the advantage of object-oriented approach is that it considers both attributes and operations. So when you design a class, of course, you have variables and you have functions, and so this becomes easier to handle. Whereas in procedural, it was data or function, whereas in object, both the data and functions have been brought together under one umbrella, and that makes it much more easier to go forward. So it is a recent approach to system development. So we call it, so we will be talking about object-oriented analysis and design, and then we will gradually move towards the object-oriented programming. I mean, not the coding aspect of it, but how object-oriented designing and analysis, and after you are done the object-oriented analysis and design, then when you go to the programming aspect, you can see exactly how you need to implement that in your system. So object-oriented development, generally, when we talk about design aspect, consists of three things: the analysis aspect, the design aspect, and the programming aspect. So essentially what you're doing in analysis is that you're trying to identify the objects that may be that may form a part of your object-oriented development. In the design aspect, you are further designing these objects and trying to understand its attributes and its different functions. Once all these are clear, then you can move on to the programming aspects. So generally, it starts off with object-oriented analysis. What happens in this is that you try to understand your problem and try to produce a conceptual model of the information that exists in the area that is being analyzed. And from use case diagram, you would have developed a little bit understanding of the conceptual model of the information that your system is providing. And however, analysis models do not consider any implementation constraints. Rather, you deal with them during the design aspects. So one thing to remember is that the result of object-oriented analysis is a description of what the system is functionally required to do in the form of a conceptual model. And I don't want you to get lost in the terminologies, because the best way to understand terminologies is through experimentation and learning, and that will become much more clear when we move on to the examples and the lab aspect of object-oriented development. So we will be talking about class diagram. So in the object-oriented designing, I have taken this class diagram which we will be talking about, and through the use of class diagram, we will demonstrate how object-oriented designing can help us in better understanding of the software. So again, class diagram is a static structure. It tells us how the different classes are interacting with the system and what is the composition. It is one of the UML diagrams. So generally, I mean, all of you may be aware that this is generally how a class is shown. So in the diagramming aspect, it's generally shown as a rectangular box, the name of the class on the top. If it's an abstract class, the name would be italic. And so these are the list of attributes, and these are the list of the operations. So I'm just touching on class diagram here. We will be talking about it in much deeper way when we are proceeding ahead. But before that, we also talk about object diagram. So these are basically the objects uh, which are telling you the information about these things. So object diagrams are also a part of class diagram. So in this particular thing, you can see that two instances are shown, and rectangle for each object. It contains two compartments. One compartment has the identifier for that object, and the other compartment has the attribute names, and the attributes have been populated for that particular object. Moving forward, so this is an important thing to remember when we talk about stages in the project development using object-oriented designing. As you can see from this, you see there is a information and there is a transmission of information that is happening. Object-oriented analysis is there. You decide the objects at the analysis stage. Now the decision for the objects will be clear only if your understanding of the problem is robust enough. And by this time, I hope that you have understood the problems that you are trying to solve in the project. Once you have decided these objects, then you decide these design. So it's an error, I think. Then you design the objects at the object-oriented design. So you see, this is directly dependent on object-oriented design is directly dependent on object-oriented analysis, and object-oriented programming will be directly affected by the nature of the design. And obviously, the feedback path is always there, so that again, because it's done in a processed manner, this back and flow of information is important, so that a finally more robust project development design can happen. So object oriented designing as a software way, remember it is composed of three things: the analysis aspects, then the design aspects, and then the programming aspects. And obviously you have to validate your analysis aspect before you go on to the designing. And when you reach the designing, just see whether or not any attribute or function is missing. And these things, the precision and the depth in these things will be greatly affected by the level of understanding you have about the problem that you are trying to solve. So in object-oriented analysis, objects are decided, and this thing I've already discussed with you, that even if you for a while forget these terms, it would come as a logical understanding that whenever we try to design how different entities are interacting in a system, at the first level you look at the entities as their names. At the second level, you try to understand, okay, what is the functionality that this entity is providing me, and what is the function for to be able to provide the functionality, what does it need? So all the parameters that those entities or the objects need to be able to function, and then on you can move on to the programming aspect. So try to imagine this flow when you are trying to develop this particular design, and that moves later on to the implementation stages. So at this question, some of you may be confused about object-oriented development lifecycle and software development lifecycle. What do you think would be the difference between these two?
Software development is a procedure in which we develop a software, and object-oriented is a paradigm in which we understand the program.
Okay. So again, so do not confuse software development lifecycle with object-oriented development lifecycle. See, the DLC remains the same, but what is being developed is different. Here you're talking about, we are moving towards the designing and the implementation phases. So essentially try to imagine it like this. So object-oriented development lifecycle is more like, what is this?
Cutting onions.
So what is, when you look at this kind of view for onion, what exactly do you think it means?
Cry. I mean,
Okay.
we get tears when we cut onions.
So you see, the layers in the onion increase when you move out from the core. Okay, as compared to generally, if you want to imagine software development as a waterfall. So the difference here is that in the early stages or core of development, the model we try to build is abstract in the object-oriented development. But As we move from early stages to deeper stages, we start focusing on the deeper level things. So as the model evolves, it becomes more and more detailed. Just like as you can see from the neon diagram, you start out from the core. As you expand from the core to much more depth, the number of layers increase. So that is important to remember. At this stage, I also want to understand from you, I hope you remember the example we had taken of automation of the baggage handling system at the Denver International Airport, and how things could have been different if it would have been approached in an object-oriented development kind of model. Because ultimately the error that had been identified during that time was that when it was expected to scale up for other airlines, it somehow had not been able to fulfill what it was expected, and ultimately it had to be brought down. So whenever you create any solution or any software, always keep this in mind that it might be subject to changes as you move forward. As your developer, it is extremely important for you to keep that space for the further development even in your absence. Otherwise, if the spaghetti code is there, then it becomes extremely difficult to improvise or work on that existing piece of code. So, what I hope you can see that even though we are not talking about coding and implementation at this stage, but we are talking about the structure and the quality structure and organization of your software design. Because once that skeleton is ready, then you try to populate that skeleton with the codes and all these things. And if the skeleton is a bit faulty, then it will almost always reflect in the end product. So that is what we will be discussing. So generally, object-oriented life cycle follows this kind of process. You identify the objects, you design the objects, and then you go on to implement those objects. But a lot of time is undertaken in object analysis and object design, and you will see when you draw class diagrams for your own projects, the amount of energy and time and thinking it takes to even think about these things. In next classes, I will talk about detail on this object analysis and object designing, and then we will talk about the basics of class diagram. We will be talking about the multiple association between classes, and then we will take multiple examples for the class diagrams and try to see that how class diagrams can help in understanding the software designing aspect. And there are different types of models also, like this class diagram is a type of static model, as is the use case model. But I really request you to look at everything that we are doing um, as a means to understand software development practically, because you yourself can see the journey that you have undertaken from functional requirements, non-functional requirements to use cases to functional decomposition to level 1, level 2 DFDs, and now you're moving to class diagrams. So hopefully you're getting a flavor of how software development generally ideally is expected to happen. And once these fundamentals are clear, I'm sure that even when you move out and work in different companies, uh, you will be adding value to the software that you are working on rather than just maybe messing up with the codes and all these things. So fundamentals are extremely important. And in our next lecture, we will be talking about object analysis and identification of objects and how we can identify different objects and all these kind of things. So more on that in tomorrow's class. So hopefully you were able to understand at least some basics of object-oriented designing, and I'm sure it will become much deeper understood in your psyche as we proceed further. And I will also share an IEEE article for your reading on this topic. I will share it in the classroom reading material section. So please go through that before you come for tomorrow's class. So that's all for today. Thank you so much. Thank you.